Three, two, one. Good evening again. This is the last video. You'll be glad to hear. This is the estimate for the trench support systems that we discussed last week in the meeting last week, actually, that we had on the 30th of uh, 30th of December. Yeah, so last Monday. So apologies, taking me a week to sort out. I just was away in Wales in the middle of the week, and then I sort of do a little bit of legal work because of my law background. So I had an issue then on, not for myself, but helping representing someone on Thursday and Friday. So it's then, and obviously then we found out that a lot of the videos hadn't been sent because they're so big. They just won't send. So I've brought back alive, if you like, my old YouTube video channel that I used to use during lockdown. So you'll find there's a couple of level 3 videos on there actually, which I did last year and a couple of years ago, which are just probably the remains of what's sort of left on there at the moment. Okay, so I've added yours now onto there. Okay, so estimating trade supports is actually quite one of the reasons why I've picked this. Not just because you sort of asked me. That did help, by the way. Sorry, I didn't want to say that you're not important. That's not what I meant. The beauty of the trench support systems, one of the conversations that we had in the classroom a couple of weeks ago was about off the job hours. And obviously I do a bit of assessing on the side. So I sort of was an endpoint assessor coordinator at one time in my career. So I know a lot about the endpoint assessments and how they're formulated. And what you've got to do, you've got to create some or write about off the job hours, and you've got to get so many off the job hours, which training is part of that. Producing work is part of that. But you've got to relate them to these off the job hours to your knowledge, skills, and behaviours. And one of the sort of knowledge and skills in particular that you need to sort of relate it to is construction technology. And the quantity surveying and the estimating unit, fundamentally, a lot of it implicitly, not expressly, not explicitly, but implicitly, is all about construction technology. Because, as I said in the earlier videos there, guys, you've got to analyse, critically analyse, in for the distinction, but analyze for the merit. You've got to analyze, which means to break something down into its component parts. And then with estimating in particular, you've got to put it back together again to create a price per meter squared or per meter cubed, a unit price per meter squared. So you're breaking it down, you're breaking down your all-in rate, if you like, and then putting it back together and putting it all together to create an all-in rate. So you're breaking it down and building up. Okay, to be able to do that successfully, you've got to understand the construction methodology and how you, forgive me using the word construct, but how you would construct a trench support system, how you would construct a foundation, a strip foundation or a raft foundation, what goes into it, what's required for it. And obviously, if you've got a trench or you're digging underground, you're digging below ground, I should say, not underground, you might require a trench support system, particularly as the CDM regulations may require this, okay? There used to be a rule of thumb at one time with the health and safety where if a trench was 1.2 meters deep or less than 1.2 meters deep, you didn't require a trench support system. But people started dying because trenches were collapsing on them. Okay, so that rule no longer applies. You might hear a lot of the older site agents or site managers talk about that rule, but actually it's under the CDM regulations now and the current health and safety laws. That rule no longer applies, and you've got to take each situation as it comes. As I said to you, you would certainly have to measure it because it's CDM. and you'd have to include it in your bill of quantities. Whether you price it up or not within the measured bill of quantities, or you measure it up as part of a system within your preliminary bill, would fundamentally be how you approach your estimating techniques. It could be that you decide not to have, not to price up a trench support system. It's been measured in the bill of quantities, but you've decided to price it up as a discrete system under something else within the preliminary bills, or you decide to price it up by battering back the excavation, the sides of the excavation. You've put them at an angle of, say, 45 degrees rather than a vertical face of the excavation. Now, if you did that, what you'd have to do then is you would have to make an adjustment for your excavation and your disposal costs, because obviously you're excavating more soil, you're disposing more soil. Okay, so that has an implication with regards to that. So you'd have to make an adjustment with regards to the rate that you create for your excavation and your disposal. Hence why I sort of said, look, you probably do that, but it's probably easier to actually price up or create an estimate, if you want, build up a unit rate per meter squared for your trench support system. Okay, so and it's a really good exercise in analytical estimating. And if you're right, and you've got to write about analytical estimating, as you know, so it's a really good example to use if you wanted to give an example, because you really need to analyze trench support systems, because there are so many out there, you know what I mean? And it generally depends on the soil type. It depends on how deep you're you're excavating, the width of the trench, what the trench is being used for, or the excavation, I shouldn't say trench, but the excavation is being used for. So all of these different things, you know what I mean? So you really got to analyze it. You've got to break it down. You got to put it together. So it's a really good example that you would use for analytical estimating. Also, it's a requirement under the CDM regs, health and safety regs. It would be probably included within the CDM health and safety pre-contract file. So that would be sent as part of one of the tender documents. So as well as looking in the specifications and the drawings, you'd look in the health and safety file as well, the pre-contract health and safety file that would have been compiled by the principal designer under the CDM 2015 regulations. Okay, and obviously, once you win the contract, you're going to become the principal contractor. Okay, so you will the file will be handed over to yourself, and you will have to update that file. So there may already be a proposal for a trench support system already in place, or they may leave it up to yourselves to decide what to do, whether it's back to back the sides of the excavation, or whether it's to create a discrete system in itself. So think about that. That's the reason why this is important. That's the reason why the unit rate with regards to a trench support system would change, fundamentally be different amongst different contractors and subcontractors, because they will approach her in a different way. Okay, they won't all approach her in the same way. Okay, and there's an argument, please, it's only an argument, I'm not suggesting that this is true, but there's an argument that a national contractor international contractor would have the resources to use a much more sophisticated trench box type system than, say, a regional or a local contractor that might prefer to use a more traditional timber-based trench support system. Okay, I'm not that and please, that's not a rule of thumb. I'm just suggesting it based on the simple economics. You might be asked, to carry out an exercise as a buyer or a surveyor or an estimator to see which system, and value engineering exercise if you want, which system in effect is actually the cheapest. Okay, based on various sort of criteria. So that's why it's a really good system. Good system, and like I say, you can use it for your off the job hours as well, guys. There's a basic system. I think that's fundamentally all you need. Is a basic system. A couple of polling boards. That's the verticals. They would be sawn timber, probably 200 mil wide by 50 mil thick, and then you would have a strut in between both of them, because you'd have a polling board on one side of the excavation and a polling board on the other side of the excavation. Okay, and they would be held back, if you like, by this strut, which is another piece of timber, probably 100 mil by 100 mil. Okay, again, sawn, treated, softwood. Okay, quite cheap timber. They come in about 2.4 meter lengths. Okay, so they come in standard lengths. Okay, and that would be cut, and it would basically create a tensile and a compressive stress, because it would be cut to quite fine tolerances to wedge in between both boards, so that you've got this pushing. You're pushing against the face of the excavation, and the polling boards there are to ensure that the lateral force that you're creating, is distributed vertically and uniformly against the face of your trenches. Okay, so that's the system, and you might want maybe a polling board. I don't know, especially if you're not using what's called a whaling board, which is the horizontal boards. If you're only using polling boards and struts, you'd probably only need, you could probably place them at every meter or every 1.2 meters. You know what I mean? So you got 1.2 or 1 meter centers. Okay, so that's simple system. The other more sophisticated type systems is where you've got a horizontal. So you've got your vertical polling boards, and then you've got these horizontal whalers, they're called. Okay, that's the horizontal board, which basically then the struts are basically wedged into. And what then is happening, you've created these tensile tension, you've created tension and compression, and the forces that are distributed laterally then along the whaler in a uniform space. So you'd have your polling boards, that's the vertical boards there, that would be at, say, maybe at every 200 centers, or sorry, not 200, sorry, maybe 1.2 meters or 2 meter centers or 1 meter centers, and they would all be connected by a 2.4 meter length of again 100 mil by 50 mil sawn treated softwood, 200 mil by 50 mil thick sawn treated softwood. And then you've got these struts which are creating this tension and compression. Now, the struts usually would be cut and sort of wedged in. Now, because it's timber, they would be subjected not just to compression and tension, they would also be subjected to shear forces and rotational shear forces, torque, we call it, okay, in engineering terms, and therefore they might have to be nailed or screwed into place to stop the twisting or the shearing. Okay, sorry, I'm trying to get into cam, or the shearing, okay, or the twisting, the torque, the rotational shear. Okay, so the nailing or the screws would prevent that. So you nail or screw into the whaling board there, or into the polling board directly. If you decided to do that, obviously there's an extra cost to the materials, because you're starting to use nails and screws. Okay, also it slows down the labor requirements, so you need a little bit more time for labor, so you have to make an adjustment for your labor as well. Okay, so you understand some of the principles. Okay, so again, I certainly wouldn't use the vertical sheeting. That's the left hand diagram. Maybe something like the right hand diagram, maybe, but with just one whaling board through the center, and sort of one level of struts, maybe something like that. However, I think the previous diagram is probably enough, to be honest with you. What I did when I went and designed it, you know, what I used to be told by my um oh gosh, by the person that was in charge of me for my asset, during my apprenticeship. He was big into drawing, and he would say, I don't care if you can draw, Steve, just do a sketch. And the nice thing about doing a sketch is it helps you internalize, it helps you actually see. As you're drawing it, you can actually see the method that you're going to use and the problems with that method. We use it today in manufacturing, for instance, in lean manufacturing. One of the things we do on the level 3 apprenticeships, we have a level 2 and a level 3 qualification for lean. And one of the things that is part of the lean culture and total quality management is diagrammatical notes, we call them, which we carry out sketches, because a picture says more than words. Picture paints 1,000 words. So I created this sketch, and the system I've gone for is a series of polling boards, 200mm by 50mm thick, some struts, and again 100mm by 100mm struts, and then a little bit of ply, 600, 400mm wide. Okay, quite cheap ply. Okay, because the width of the trench is not that wide, the depth of the trench is not that deep, and I think you can just about get away with that health and safety wise. But remember, guys, that you would need this signed off, this design signed off by somebody competent. So when you did your method statement based on these sketches, and your risk assessment based on these sketches, that would have to be signed off by somebody competent in accordance with the CDM regs and the Health and Safety at Work Act. Okay, so all of these things, need to be taken into consideration. Not just about drawings. It's not just about specifications. They're important. My God, yeah, but it's also the health and safety file, pre-project health and safety file, pre-construction health and safety file, I should call it, and also the construction health and safety file, between the principal designer and the principal contractor, who will be in charge of these files. Okay, so it's in relation to that as well. So there's my methodology, there's my method statement based on that drawing. I think mine's too sophisticated, to be honest with you. Okay, I think you could simplify it. All right, so I've given you scope to decide what you want to do. All right, so but base it on a similar system that I'm proposing you. Don't use a trench box, I don't think, unless you've already used one, then use it. Okay, but simple, straightforward timber system would be fine. So you need to calculate the total amount of quantity of materials, timber required, including any nails or screws that you propose to use. Divide that up by the number of uses, because you can reuse this stuff. It goes back to the sustainability and recycling agenda. Okay, I think you can use it up to about 7 times maximum, but I've said about 4 or 5 times, so I've taken a middle ground there. Okay, and then so you get a total cost divided by the amount of reuse that you're going to get out of it, and that gives you a subtotal for the cost of the materials. Then obviously you're only going to use the labour once, so it's not being so you can't divide it by 5 or 7. So get a full labour cost, you're going to need probably a timberman and a general operative. Okay, and then add your labour to your material cost, and then find a total area, and then divide the labour and material cost, the total labour and material cost that you've added together, by the total area, and that will give you a cost per metre squared. and then add on your percentage and overheads for profit. Sorry, your percentage for overheads and profit. Okay, that's fundamentally it. You know, that's it in a nutshell. Okay, so the quantity of timber. Remember, you only require some cheap stuff, sawn, treated, because it's external works. Okay, for poling boards, that's the vertical boards, probably 200 mil wide by 50 mil thick. Okay, which in old-fashioned money is 4 inches by 2 inches. Okay, so 4 by 2, you might hear some of the older site managers say. Okay, but it's fundamentally 200 mil by 50 mil. Okay, use your center line, which is around 76 or 77 meters in your case. I've just used 50 meters because it's easier for my maths. So I've got a center line of 50 meters. I know I would need vertical boards one side of the trench and vertical boards on the other side of the trench. So I've got to double it. So the length can be anywhere between 300, because I got a 600 mil deep trench and 0.6 meters. So anywhere between 350 and 600 mil. For the sake of maths, I've decided to use 600 millimeters, which is 0.6 meters. So I've also decided to place my poling boards at 2 meter centers. You might decide to put them at 1 meter or 1.5 meter centers. It's up to you. So I divide the 50-meter center line by the length of centers that I'm using. So 2 meters. So I divide by 2 meters. So I need 25 poling boards plus one extra. I always need that one extra for the end. Okay, so don't forget that one extra. So I need 26 poling boards or 26 lengths of timber, 200 mil by 50 mil thick. Okay, on one side of the trench, and I need them on the other side of the trench. So I double it and it gets to 52 boards. Now, I've said they're 600 mil long. I think that's too much. So about 400 mil or 300 mil would be enough, but I've said 600 mil. So I'm going to multiply it by 0.6 meters. And what that means is 52 times 0.6 meters gives me 31.2 meters of timber in total. Okay. I went on the internet and they cost anywhere between £8 a metre and £20 a metre. Okay, I chose £15 and 5 a metre. Okay, and they come in 2.4 metre lengths. So I had to make an adjustment because I've got to buy them in 2.4 metre lengths. So I've got to make an adjustment. So I don't need to make an adjustment for wastage because the 2.4 metre lengths should make that adjustment for me. Okay, and by making that adjustment then I found out that I need £505 and 68 pence in total with regards to the amount of poling boards, and that's a total cost. So this my poling boards done. Total cost of the poling boards. Then I did my struts, 100 mil by 100 mil. I need 26 of them because they're holding up 26 uprights on one side of the excavation and 26 on the other side of the excavation. I only want one in the middle there. I don't want two, because if I was going deeper, I might need 2 struts or 3 struts per poling board, but I only need one per pair of poling boards. Okay, I've calculated the length of them. Okay, by making adjustments for the width of the ply and the width of the poling board, 50 mil, which is 100 mil, and 36 mil because I've used 18 mil thick ply. So I've made an adjustment there, and what I found was that the width I require is 164 or 165 mil wide. Okay, I probably would have made an adjustment to 165 just to sort of make sure that I can sort of wedge those poling boards apart. Okay, so so basically 0.165 or 0.164. All right, I need 26 of them. When I multiply that, it gives me 4.26 meters in total. 4.26 meters and comes in 2.4 meter length, so 4.26. So if I divide by 2.4, I worked out that I can have 14.6 lengths, so that's 14 lengths that I need. Okay, so when I make that adjustment, I actually need 2 lengths of 2.4 meters. Okay, which would give me 28 struts actually, and I need 26. All right, so that's me calculating a very, very accurate, or a very accurate wastage factor there. Okay, so they're about, each length is about £10 each actually. I think you can get it cheaper, by the way. I think you could probably get the timber, that all my timber price is actually a lot cheaper. Okay, because I just went on the internet and the first thing that came up I took. All right, you guys are buying in bulk, you probably could get that for probably £5 a length, which is £10. So you could probably, your timber prices, your material prices are going to be a lot cheaper than mine. Okay. Then the whaler boards, that's the horizontal boards. You could use just one whaler board if you wanted to, and the whaler board could be a bit of timber, 2.4 meters in length, basically 200 millimeter board by 50 mil thick. All right, that goes along the either side of the trench, and then just put a strut and a pole-in board up as well. But what I've done, I've gone for the cheaper option. I think this is the cheaper option because it's much quicker. I've used some bits of marine plywood. They come in sheets. The sheets are 2,440 millimeters long by 1,220 millimeters wide. I can cut that in half, just cut it straight in half, and that will give me 2 lengths, okay, that I need. Okay, so one board will give me 2 lengths of 610 mil, I think it is, wide. If I wanted to, I could then reduce that and say the width is going to be 400 mil. The width of the whaler board is going to be 400 mil rather than 600 mil, and what that will allow me is to cut one sheet into three strips of 2.44 meters long. Okay, that would actually reduce my material price. However, there are extra cuts, so I would have to add it on to my labor price. Okay, so my labor cost. So I've got to, it's basically balancing act. Okay, I've got to have this flexibility between labor costs and material costs. Again, I haven't had time to really analyze that, but I'm just sort of saying, if you've got time, analyze that. Analytical estimating, which is the best one. I've just gone from 600, so we just cut it in half very quickly, and that's my whaling board. Okay, and what I worked out, if I've got a 50-meter center line, that's all I need is 21 boards, and that includes any wastage as well. And a board is about £45 a sheet. If I'm honest with you, I think you could probably get that down to about £30 to £35, you guys. Okay, and my total price then is £945 for my whaling boards. Okay, so total cost for my materials, then I add it all together. I don't think the struts are reusable because they're so narrow. I don't think you can reuse them. I think you can recycle them for something else, but not for this particular operation. So I've said the struts, you can't reuse them, but I think you could reuse certainly the pole-in boards. That's your 200 millimeters by 50 mil pole-in boards. That's the vertical boards, and I think also the ply could be reused, and I said about 5 times. So what I've done is I've added the total cost of the pole-in boards, which is £505.68, added it to the total cost of the plywood, which is £945, which gives me a total price of £1,450.68, and divided that by 5. So that's in total, because I can reuse it, I've only got to buy it once and reuse it 5 times. That actually means my cost is reduced then, my total cost that is, to £290.14. What I need to do then is add on my £20 for my struts, or my £10 for my struts, okay, which I'm only going to use once. So that's £310.14. Okay, so my total cost for the timber is £310.14, which is quite reasonable. And like I say, you guys could probably get it cheaper than that because you're buying in bulk. Labour then, slightly different. What do I need for labour? So I need a timberman. That's an operative. That's a high grade operative, because they are not quite a carpenter, but they are used to doing carpentry work. Okay, so they're going to get paid the higher rate for an operative. So I've given them grade 3 out of the working rule agreement, which is £21.73 an hour. Okay, I'll also need a general operative when I'm sort of putting it all together. So, and I've used just a basic grade, £20.37p an hour. So when I analyse careful cutting and measuring of timber, okay, and of the ply, I would guess it would take around 4 hours to cut it, and they're doing all of this work on their own, by the way. So it takes about 4 hours to get all the materials, to cut it to length, and move it around the site. You could say it's going to take longer than that, Steve. It's going to take 6 hours. It's going to take 8 hours. So I said, sorry, not 4 hours. I said 6 hours. Sorry, not 4 hours. Okay, so I've multiplied £21.73 by 6. Forgive me, there's a slight error there. So by 6, which gives me £130.38 in total. Okay, then I need the timberman and the operative working together to put the system together. So it's all been cut now by the timberman, and then a bit like a Lego set or a Meccano set, we're going to put it all together. And I need 2 operatives to make sure I can do that. And I said it's going to take between 6 to 8 hours. All right, so 6 to 8 hours there. So I add the timberman and the general operative together and multiply it by 8, and it comes to about £336.80p. I then got to dismantle it. So I said, look, because it's got to be carefully dismantled, in some books you'll see the labourer dismantling it, the operative, the general operative dismantling it. In other books you'll see the timberman. Because it's got to be careful, because you need to reuse it, I think it would be better if the timberman dismantles it carefully for reuse. So I said the timberman would take about 3 hours in total to dismantle. So £21.73 times 3 gives us £65.19p. What I do is I add those costs together to give me a total material cost, which is £532.37. Now, I've just guessed that. I based it actually on some reading I've been doing. Sorry, on this book here. Okay, it's an old book that I was working out, that I work out of sometimes. It's a 1998 book actually, but so some of the rates in there now are a bit old, but it's sort of, and they designed a different sort of timber system than I did, but it's based on fundamentally on something that they sort of say in there. Okay, fundamentally that's what the total cost is there. Okay, about £500. I think maybe cutting it might not take as long. Putting it together might take a little bit longer or a little bit less. And then dismantle it might take less or might take more. You see, I'll leave it up to you on what you decide. Okay? All right. Right, now we need the cost per metre squared, because ultimately that's what's going to go into our bill of quantities. And basically I add my two costs together, okay? My cost for labor, my cost for materials, and then I divide by the total area, okay? Remember, okay, I've got two faces. I don't mean two faces, I'm not a two-faced git. I mean, I've got two faces to the excavation. So I've got a center line, but I've got to multiply that center line by 2. Okay. And the depth I'm using is 0.6. It could be 0.3, it could be 0.4. Okay. So what that gives me is 60 meters squared in total. And then, so my total for labor and materials, I divide by the total area. And what that gives me is about £14.04 a metre squared, which I thought wasn't too bad. I think you can get that down because the material price, you could reduce the material price by, I reckon, about 50 to 70%, sorry, about 30 to 50%, to be honest with you. So you could probably reduce that down to about £10-12 a square metre. And then obviously you'd add on your overheads and profit. And fundamentally, that's all you've got to do. It's not as difficult as it seems. It relates to construction technology and having a sort of understanding of how things go together. If you don't have that understanding, and it's a little bit complicated, because, I remember being an apprentice, and, I might have said this when I was teaching you guys. I could never for the life of me work out from the diagrams, the two-dimensional diagrams that they used to give us, in university and sometimes on site. I couldn't work it out. I really couldn't work out. I couldn't sort of see it in my mind's eye. And I suppose because I do suffer from ADHD, my mind rushes, boom, 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 and sometimes I can't see. What I was taught by one of my professors at the University of Wolverhampton, who would, who would then go on to work for me at University College Birmingham as the CIOB lecturer there. I always find life ironic. One of the best lecturers that I actually that I work with as a student, as an apprentice at the University of Wolverhampton, he taught me to sketch in 3 dimensions, and he taught me how to change a perspective using oblique sketching, using 2-point perspective, using 3-point perspective, single point perspective. He taught me to do that, and once I did that, I could start to see what a strip foundation. I could start to see things. I also had, as I said to you, I had a very good person that oversaw my apprenticeship, and he believed a lot in diagrammatical notes to break everything down to help you analyze. And when you've got a mind like mine that can jump all over the place, you need that. You need to settle down. You need to settle yourself down to be able to analyze. Especially back then, I used to smoke a lot of cigarettes back then. So if I was having sort of nicotine withdrawal, I could be doubly edgy, to be honest. That, and with caffeine, I could be doubly. It didn't help me at all, really. But by sitting down and drawing, it helped me sort of see it. And to be honest, these days, there's a video about it actually from when I taught my level 3s apprentices about 4 or 5 years ago, still up on my YouTube page there if you have a look. But what I'm trying to sort of say is, if you're struggling to look at it, try to draw it. Even if I'm not the best drawer in the world, I don't purport to be, but I can do a pretty good sketch these days as a result. You know what I mean? It's good for you. Implicitly, it links to those knowledge, skills, and behaviours that are required to do your off-the-job hours. And it relates to construction technology. It relates to design. It relates to a measurement and estimating. Okay? And it's teaching you to analyze, which is a key behaviour that's required. It's teaching you self-discipline, which is a key behaviour that you need. Okay, and it works honestly. I can only say from my, for me, I draw. You saw that drawing there. It's not fantastic. Took me about 2 hours to do on a Sunday. I was sat outside. It was a cold day, but the sun was shining. I sat outside under my tree that I've got, my little silver birch. I know I sound a bit hippy dippy, but it just relaxes me. It allows me to chill and to focus. And that's just me personally. I'm not under any great need to justify my off the job hours. Okay, so I just thought whilst I was doing this sort of presentation, I would link it back to that conversation that we had a couple of weeks ago on off the job hours, okay, to help you sort of fill those things in, because I know a lot of apprentices use it, leave it to the last minute. Got 500 apprentices as part under me as a manager, in manufacturing, okay, but what I'm trying to say is, we do teach, as part of our apprenticeship scheme, we do teach a process called lean at level 2 and level 3, and we encourage our students as part of lean. One of the, we use the Toyota system, which is in the Egan report, by the way, as well, because he wanted construction to use the Toyota system as well. And the Toyota system is engineered by engineer Ono, and Mr. Ono, okay, who was a Japanese engineer in the 40s and 50s. And he's basically the godfather of lean, and he tells you to write diagrammatical notes because a picture says 1,000 words, and it helps you to internalize something. So I just sort of, sorry to go on a bit there as well. All right. I will post this now, and I'm available. Like I say, this is the last video that you wanted. Apologies for the sort of delays. There's a combination of factors, obviously holiday and all of that, but you can see by the amount of videos being produced now at the moment, I'm back in my work mode and focus, even though I don't go back to work till tomorrow. I'm available, obviously, from tomorrow evening, and fundamentally, that's it, really. Okay, so if you need me, email me. I'll start looking at some things as well. Some any the people have sent me as well. So I'll give you a little bit more detailed feedback as well, formative feedback. All right. Thank you, guys. Take care.